Have you ever considered what happens to rainwater after it hits the ground, especially in developed areas? It journeys across our landscapes, flowing over streets, lawns, and construction sites. But this journey involves picking up much more than just water. Stormwater primarily carries non-point source pollutants by acting as a powerful physical transport agent, mobilizing contaminants from widespread land-based origins and channeling them into waterways during and after rainfall events. The core mechanism behind this transport lies in the erosive power of water and its ability to dissolve or suspend substances. As rain falls, it creates runoff that gains velocity and volume, picking up loose particles, chemicals, and organic matter from impervious surfaces like roads and rooftops, and permeable areas such as agricultural fields and suburban yards. These pollutants, unlike those from a single pipe, originate from diffuse sources, making them challenging to pinpoint and regulate. The energy of the flowing water dislodges soil, washes away chemicals, and carries debris, depositing this mixed load into storm drains, streams, and eventually larger bodies of water. To understand this process practically, imagine a typical rain shower over a residential street. Oil and grease from cars, fertilizer and pesticides from gardens, pet waste, and litter are all present on the surface. When the rain starts, it begins to wash these items away. The water flows downhill, concentrating into rivulets that pick up more material. It then enters a storm drain, which, unlike sanitary sewers, typically flows directly into local rivers or lakes without treatment. This directly transfers the accumulated pollutants from land surfaces into the aquatic environment. A key concept here is the first flush effect, which describes the initial surge of stormwater runoff carrying the highest concentration of pollutants accumulated on surfaces during dry periods. Engineers and hydrologists often target this initial runoff for treatment strategies because of its disproportionately high pollutant load. Understanding this temporal variability is critical for effective stormwater management, differentiating between the ongoing transport of pollutants and the concentrated impact of the first flush. Ultimately, recognizing stormwater's role as a primary vector for non-point source pollution empowers us to implement more effective land management practices and urban planning. By controlling runoff at its source and mitigating the contaminants present on land surfaces, we can significantly reduce the overall pollutant load entering our vital aquatic ecosystems, ensuring healthier water for everyone.
If you love learning about water, like, subscribe, and keep exploring with us.